Hello to everybody. This is the first labs of the course that is called Geomatics for Urban and Regional Analysis. And in this lab, we are starting with the part that is related to the remote sensing techniques. And in order to do that, yeah, you remember I shared and you have all the information concerning the software, and you can find everything on the portal of the course and also in the Dropbox folder that I shared with all of you. So I hope that you have installed the software, and the software we will see all together, that is called Envy, and the version of this Envy is the version 5.3. And you have installed that on your PC, and you have activated that with the license.dat file in order to activate the software and to have that running till to the end of the semester, at the end of this course. So you were provided by a couple, at least a couple of versions of the software that is concerning the two main operation system that are, Windows for I think the more of you, and the Mac OS operational system for the other who are operating with Macintosh. So I think that you have activated the software and you have installed, of course. You will see, you are seeing that I'm using a Windows version, a Windows PC, and so I'm starting the software, just going in the start button. Of course, it's more or less similar to the Macintosh users. So I'm going to the software, and you see here I have the folder with MV5.3, and so just a brief introduction to what you are finding over this arrow. So you see we have different version of MV. You see here we have MV5.3 in different version. You see here 32 byte, 64 byte, and then we have for 32 and 64 byte the same version of MV5.3 plus the IDL 8.5, that is a thing that I will explain to you, and then the MV5.3 help. Then you have the same things as before, but it's not the MV5.3, but is the MV Classic 5.3. And you cannot consider this MV Classic because it's an older version, an old-fashioned version that, for example, I use last year with other students. But with you, I will use this classical, did not classical MV version, the more updated. And then you see here we have MV LiDAR, that is another application. The license wizards, in order to to manage the license, don't use that because as I explained to you, you have to put the license.dat file in the right position in the root system of the installation in order to to have the software working. And then these other things here, LM tools, and then tools for the art tool box help could be important when you will switch to the digital mapping application using ArcGIS. And so, this is the way to connect in a direct way Envy with the Esri suite. So we will concentrate on the first part. So, which is the difference between 32 and 64 bits? Well, that depends on the processor you have mounted on your PC. So, for example, I'm using in this moment a laptop that is working at a 64-bit. So I will start this version. While these two things here are the same software, with the heading of IDL 8.5, just to introduce these things. And I mean, I only introduce that because we are not using IDL. IDL is a programming language, a particular programming language. This is the version 8.5. That is the programming language that has been used to build up Envy itself. So I mean, you can use the application and the programming language in which this application has been developed. Why that? Because I mean, for example, for advanced application, you can use the framework of this programming language in order to add some customization or to write some some lines of code in order to add some new function or to perform some particular application. So I mean, when launching Envy and IDL, the user can customize his application with more and more function. But this is not the case because I mean we have only few hours in order to use this Envy, and I mean, we cannot, of course, go in depth with the programming language of Envy itself. And then you see here you have Envy 5.3 help. That is something that you will find in the software itself, but you can also launch a standalone if you need to have some information about the usage of some function in the software. So from now on, I will start for these labs the MV 5.3 at 64 bits. So I mean, I'm clicking this icon and you see the software is starting. You see the original Windows, I mean the original logo, and you see this is the Envy software. Now I'm going to describe the different part of this software, but I'm starting with the name of this software. This software has been developed, let's say, at the end of the 80s and at the beginning of the 90s of the last centuries. So that means 19 at the end of 1980s. So I mean, it's more or less more than 30 years, 30 years that Envy is active and operational. So it's a very long life for a software. And I mean, the Envy, the name Envy, is an acronym, a very reductive acronym that stands for environment N, for visualizing V, images I. So I mean, you see, it's very reductive, this acronym, because of course this software is not visualizing only images, but I mean, this is what we will see in these very first labs, but you will see in the other 5 labs that I mean the functions of Envy are much more that of course visualizing, but there's a bunch of different possibility to process also in a very precise mode images that can be acquired by whatever sensor you want. So I mean, this is the Envy software. I mean, the layout of the software. And I mean, you see, we have different parts of this software. I mean, apart from the bar that we have on top of the layout here, you see we have some different menus. This is the principal menus, the main menus. And for example, you see we can have these windows of commands. And you see here, for example, when I'm just selecting, for example, here in File, Open As, you see I have some other menus, and I can have, you see here, at least 4 different branches of different functions, because it's related to a particular function of opening of files, in particular for optical sensor. In this case, this ALOS is a platform, is a Japanese platform, and you see you have here some different possibility to open these particular images. And for example, also here you see you have 5 different branches, because if we are going to OpenAI's optical sensor, Airbus, we have Pleiado, we have also Spot. There are two kinds of different satellite platform where on board is mounted a particular sensor that is acquiring this kind of images. All right, so we have all these different things here. Okay, and what is very important here, apart from the commands that you can get, is the fact that you have always this help function. That is, you remember at the beginning I mentioned the fact that you can also launch standalone the help function, but of course this help function is integrated directly in the software itself. So I mean, you can when you have some doubts and you don't remember where particular operation you can find particular operation in the software, you can always go to the help function in order to get all the information. In order to have the help function, is really necessary to have a connection with the internet, because usually is going to take all these information out of the producer, MV producer websites, in order to have all these things. I also encompass in the didactic material also a PDF version of the main function of the MV, so you can find also that here. But anyway, you will see, just starting with today, it's much better to have, of course, a direct connection to internet when you are launching and when you are working with the software, because I mean there will be some function that are active only if you have a connection, because it's going to harvest some data in internet and to display on your screen the data. So you have here the help function, and then you see after just below this menu, this principal menu that are divided in file, editing, display, place mark, and we will see what place marks are, views and help. Here you have a list of icons, and this list of icons, where now there are only two that are available, the open and the data manager, and the data manager is very important, you will see, and they are only two active. Yeah, you see you have more other icons. What is the meaning of the icons? I mean, there are, of course, shortcuts. I mean, shortcuts to very common commands that we are using. For example, you see here, we have this data manager, and when I'm going to the mouse to point the icon without any click, you see you have a description, a label with the description. This is the data manager. Usually, these icons corresponds to something that is usually in the upper part of the menus or in other part of the function, not here. So for example, you see here, data manager, if I'm going to file here, I will find the same function here, you see, the data manager. So pay attention. So sometimes for very common commands like data manager, I have the icon here. I have the same commands here in one of the different menu. And sometimes I have also shortcuts to particular button on the keyboard. For example, you can, if you have not changed anything of the original setup, the data manager could also be launched simply pressing the button F4 on your keyboard. So in this case, for the data manager, you have three different possibilities to get these commands from here, from this menu, using a button shortcuts or using the icons here. And usually you can find the same commands. There are many commands that can be found in different position of the menu, of the icons, or in shortcuts. All right. So These are the different things, and then we have other three different windows. The first one is this one, and you see that in Envy, usually every single windows on top in a darker color, in a darker gray tones, you see here, have the name of the windows. This is very important in order to know what kind of processing or operation you are doing, simply reading the name of the windows on top of the windows itself. So this is the layer manager. This is a part of the layout of the setup of Envy. And you see the layer manager, you will understand better these things when we will load some data, is the windows that allows the user to manage the different layers. What are the layers? The layers is something that is very similar, and also the setup is very similar, for example, to ArcMap, for example, ArcGIS. Here you have all your data, and the data could be, of course, raster data, images, or vector data, maps, and you have all the things there. So you will have a list at the end of data available to be, for example, displayed or available for further processing. And you can, of course, manage all this data from these particular windows here on the left part of the windows. I mean, you will understand very soon that when working with images, I mean, you need to have, you are creating more windows. So sometimes it's better not to have these other windows in the middle of the windows of the visualization, because the windows where the data will be visualized is the bigger in the middle of the layout of the software. This one, look at the mouse. This is the main windows when all the data will be visualized. And sometimes could be very useful not to have only this area, but to have also the other area. For example, the area that now is occupied by the layer manager. I remind you that being in a Windows system, you see here, I can change the dimension of the different windows. You see here, I enlarge the layer manager windows, but I mean, I can, of course, also reduce that, but I can do also other things. You see here that on top, on the upper right part of the windows here of the layer manager, I have these icons, you see, and this icon is called detach. What does it mean, detach? That if I'm clicking on that, you see I can detach these windows and I can have a floating windows in order to move that whenever I need it. For example, I can close to icon here, all right, so I can remove these things here. And when I close that to the icon, so you see I can have these windows here, you see? When I'm clicking here, okay, I can have the detach windows. And if I'm going here, I can show the panel, you see? I can retouch these windows. So again, now I can detach that, you see? Now it's here. If I'm closing because I don't using that, for example, I minimize the windows, you see I can close, I can open that here in the show panel, all right? If I have been detached these windows, and then I want again to attach that to the original position, you see here the icons, upper right here, is now converting to attach. So if I'm pressing this icon attach, you see the windows will be replaced in the original position. Then I have also these other windows, the third one, Windows, let's say the last one. And you see, this is the Windows that is called Toolbox. Also, this Windows you see has the icon of the touching. So I mean, I can use that enlarging the display data windows as I want. And I can again here attach these windows. Let's attach that again. And you see here, I have some different folders. These are not really folders containing data, but these are folders containing, for example, let's go to the radiometric correction, containing procedures. So, for example, you will see that when we will use radiometric calibration, you see I can just click on radiometric calibration, all right, double click with the left button of the mouse, and I'm launching the procedures. And for example, in this procedure, you see the first windows is select your input file, all right. So here you have, I'm closing this root system of commands. So you have all these different menus. These folders are menus. You can also add some favorites here. That are functions that are widely used. And here you have some different things to perform on the image. For example, classification. You see, you have some different algorithms of classification, and you can choose the algorithm you want to perform in order to extract information from the data using this system. For example, you see we will use some supervised classification, and for example, when using, for example, the minimum distance classification, you see we can launch that from here. All right. So this system, if you know, is very similar to the RMAP, for example, where you have the same layout of the software. So you have a Windows when you are where you are displaying the data. You have the layer manager, or what is called in the Esri platform is called a talk, that is the table of contents, that I mean is something very similar to the layer manager. And then you have the arc toolbox, that is the same things here. So you have the toolbox that are something that you can do on your data. Of course, as in ArcGIS, for example, if you know where is your function here in the toolbox, you can find that in this folder system. But you can also search something. For example, if I'm searching, for example, here, minimum distance, you see, it find with only with minimum. Here I have the results of the searching, and if I'm clicking here, I mean, I'm going to the same position as before. So I mean, this search box here is very interesting because it's not only an help request, but is the possibility by using keywords to find the procedure you need to have that available below in this toolbox windows, and then to launch the procedure from the toolbox windows. Here, if I'm delaying everything here, you see, I will return to the list of all the different procedures. You see here there are hundreds and hundreds of different procedures because I have all these procedures and all these commands that are or in icons here or in these menus. So you see I have thousands of different possibilities, thousands of different procedures here. And I mean, of course, we are not doing everything. We will do just the essential parts, the essential processing and displaying of the images in order to make you, give you the ability to process, especially in this part of this course, of these geomatics for urban and regional analysis. In this first part, you will gain the ability to work with raster data, mainly satellite data. So data images that are acquired by sensor mounted on board of satellite. All right, now after this explanation of the different windows of the layout of the software, we can start straightforward with displaying some data. And so in order to display some data, of course, we need to load this data. So in order to load the data, we can go, for example, in the main menu here in File, and you see Open the Data. And I'm not explaining why we are performing this operation, but for this very first opening, we are using this command. So we are not using the general open, but we are using the open as. Then we are going to optical sensor because we will use mainly and for the most part of the course just the optical sensor, and we are using data acquired with an optical sensor that is mounted on board of the Landsat platform, the American one, and we are opening this data using this particular format that is the GeoTIFF with metadata. So you will see, you are seeing all the different part of the opening. So in the main menu, let's do that again. In the main menu file, you see I'm selecting open as without any clicking anything. So I'm going then to the optical sensor that is mounted on board the Landsat platform, the satellite. And then I'm opening with, you see here there are different formats of the data. I'm opening again with this GOT with metadata that usually is the format of the data that you can have and you can get when you are going, and I will show you that in the theoretical parts, how you can go to the NASA website and download data from Landsat. You see, we are using this GeoTIFF with metadata here, all right? And now I'm clicking with the left button of the mouse, and just before going here, you see we will see in this position. I don't know where you have put your data, but you will have somewhere on your hard disk on your USB keys or USB disk. The data are in this folder. This is the folder that I shared with you in Dropbox. And this is also the folder that you can find on the portal of the course on the Polytechnical side. So I'm clicking on data and I'm opening this Northwestern Italy dataset. And you see that out of all this data, I have this file here. This file here, you see, it's a bunch of different alphanumerical character. You see, I have L7, 11, 94, 29, underscore, and all this number, and then underscore MTL. What is really important here is the fact that when you are downloading this data from the NASA website, you will find all the data with this file that is the metadata file. What is the metadata? The metadata are the data that are describing the data itself. So, these are all the ancillary information that are describing the images that were acquired by these Landsat, the sensor mounted on board of this Landsat satellite. And how you can understand that this is the metadata file? Because this is there is this MTL. You see here this acronym here that stands for metadata list embedded in the name of the file. And you see it's a very simple documents that is, a text file. You can open that or also with a simple, for example, notepad in MV. And this is a text file that you can read with all other browser, for example. So if I'm selecting these things here, I just click open from here, and you see, when I'm clicking open, you see, you will see an image here. All right. So when looking for this image, and now this image is displayed in the center of the of the windows, in the data windows, you see that having this image, you see that now a bunch of different icons are now active. Of course, these if they are active, That means that these icons are working only when you have an image that is displayed. All right. So, what is changed? I mean, of course, the windows in the middle now is displaying an image, but also the layer manager now is displaying this data. And you see, I'm enlarging these things here. You see, I have now these things here. That is the name of the image. You see here with all these different characters. This is the MTL data. And there's another thing added here that is multispectral. What does it mean that it's multispectral? That means that is a multispectral acquisition. That means that from the same sensor, I can acquire, as I mentioned you, since the beginning of the introduction of the course, we can acquire with the same sensor over the same area, the same piece of Earth's surface, different images, every single image in a different spectral bands. And the concept of the spectral bands, we learned this concept just at the beginning of the course. So, I mean, there are multiple images here. And then I have also another things that is the overview. What is the overview? If I'm clicking and I'm visualize, I'm displaying this overview, just checking this box here. You see, I mean, this is the overview. So this is the entire image because now, right now, by default, because these are the options that are predefined in the software installation, but you can, of course, change. I mean, this is only a very small part of the image because this is the whole image. And now we are working only with this visualization. So using the overview, for example, if I'm moving here, you see I'm moving to other part of the images. And for example, we will see that this part here is Torino. For example, if you are going here, for example, here, you see, just on the coast of the sea. So here we have Genoa, for example, and other different places. So you can also work on that, all right? So if I don't want to display these windows, I just uncheck this box for the overview, and of course, the windows is changing. So when I visualize that, so you see now I have some different windows active. And for example, having these windows active, I can just use these hands in order to pan the image. You see here, I can pan. Of course, I can fly. This is another icon that is quite interesting because, for example, if I want to follow the coastline, I can use this icon and then clicking and keeping clicked the left button of the mouse, you see I can fly in different position. You see here I can go to all the coast without keeping on pan the image. So you see, for example, if I'm going north in the image because it's georeferenced, you see I can follow, for example, a river here, and I can go and following river or mountains. You see here, this is the Po River, and I'm going, for example, in the middle of these clouds, for example. So you see the fly option is quite interesting. And then I have also here, you see the possibility to zoom. And if I'm, for example, I'm zooming out, you see, just clicking this button, I can zoom out. But I mean, what is very important in MV is that you can use all the different buttons of the mouse. For example, till now we have used only the left button of the mouse, but I mean you can also use the wheel if you have the wheel. And I mean for this software, I'm switching to the fly menu here, so the fly icons to the select one. If you are using the mouse, it's better to have a mouse with a wheel because with the wheel, now I'm just rotating the wheel. You see that I can change the zoom interactively. And then using the pan, I mean, you see, I can zoom in a very smart way using the wheels, okay? Not using this icon here, the zoomed in or out. Of course, you can also zoom with the windows. For example, here, you see, using this icon here. But if you are having a wheel on the mouse, it's much better. I mean, of course, you can also zoom with the icons, but with the wheel is more is quicker then. And I mean, I mentioned the fact that we are using in MV also other button of the mouse because, for example, if I'm using, I can also use the right button of the mouse because, for example, you see now I have these zoom windows. I'm going to deselect just not to have some mistake or performing something wrong. But if I'm going to the layer manager, you see to the name of the layer manager, and I'm clicking with the right button of the mouse, you see here, I have this pop-up menu, and this pop-up menu that is activated over the name of the image that I have in the layer manager is adding some other different options. So for example, just clicking that, I can remove these things here. I can change the RGB bands, and I will see just before. I can view the metadata, quick starts, and so and so and so. So many different options. All right. So you can then explore the image just changing the zoom ratio or just moving in the image. And when we are moving on the image, you see this image, I'm just clicking again and I have the visibility of the overview. You see that this image is at least rotated, and you see that I have these yellowish things here that is white in originally on the image, this border here, this triangle here, because I mean, here there's a problem. This image is georeferenced, and in order to be to reproject this image in a particular geographic reference system, I mean, due to the fact that the orbits of these satellites that is embarking the sensor is inclined if you are taking into consideration the plane that is crossing north and south pole and is inclined, these orbits, I mean, the acquisition is inclined. So when you are reprojecting the data, I mean, the image is at least rotated. And unfortunately, using a classical software of visualization, we cannot just store the data in a rotated way, but we need to inscribe this image in a larger frame here, where you see all these background values are not data that are coming from the ground, but they are simply used to encompass the original image in a larger square or rectangle in order to store and then to visualize the different data. So I mean, when we are moving here, you see here, and this is the original, this is the framework that is containing the image. This triangle, this white triangle, are not data acquired by the sensor, but they are data that have been used to fill with a particular number the image, the frame that is containing the image, and not these things here. All right, so I'm closing these overview windows. All right, so this is the different, this is the image. And so now, I mean, these are the image, and you know, and this is now the most important things to do that I mentioned before at the beginning, that, for example, just taking into consideration the data manager windows, I can check and I can pick up this function from the main menu in file. I can use the F4 shortcuts on the keyboard, or I can use this icon here. You see, data manager. So click on data manager. All right. This is a very, very important Windows in MV. I mean, why this is a very important Windows? because I mean this windows is showing you what is currently open. All right. And in this way, when we have upload this metadata file that is concerning this Landsat acquisition, you see, in reality, we don't have only this image, but we have a bunch of different data. And in particular, and this is the example of Landsat 7, and these alphanumerical characters that we have here in the as name of the file is something that is coming, as I mentioned you before, is coming directly from the NASA website where I downloaded this image. And for example, L7 at the beginning of the file stands for data acquired by a sensor that is mounted over Landsat 7. This 194.029 is a coordinate system of the scene acquisition. I mean, all the image here that I have in the overview, so you see that I check the visibility of the overview also if I have the data manager windows opened. I mean, this image here is called scene. And so there's a reference system of this scene, and in this case, the reference system is row 194 and line 029. This is a conventional system. It's not very important for us. That could be if you are downloading more and more images. But I mean, it's just something that is related to this particular scene. And then you see you have some more information. But what is very important is that the last 8 digit you have before the MTL indication here, you see is 220 02 09 28 is the acquisition date in the American format. So that means that this acquisition were performed in 2002. So I mean 18 years ago. Oh 09, this is the month in September, and the 28th. So I mean this acquisition was performed on the 28th of September in 2002. So, I mean, you see that this name is very important because you will see and you can understand that the data acquisition is very important because, for example, here in September, you can just refer to the vegetation in a particular state of the vegetation, but mentioning the facts that, for example, this acquisition was performed in 2002, so I mean 18 years ago, there were things over this area that have been changed in these 18 years. Maybe some things are not still there, or there are newer things, newer surfaces, newer features on the image. So I mean, the acquisition date is very important. So you see, usually when you have multispectral data, I mean, this is the first example, you have different data sets. And in this case, you see we have 3 different data sets. The first one is composed, you see, by 6 different spectral bands that for this sensor are conventionally named band 1, band 2, band 3, 4, 5, and 7. There's not a band 6. I will explain that afterwards. And here in brackets, after the conventional name of the bands, you have the central wavelength of the acquisition. So I mean, you see, for example, band 1, the central wavelength is 0.48 microns. What does it mean, these things here? That the band 1 is acquired by the sensor in the subbands of the visible, and in particular, the blue band. The band 2 with 56 microns is the band of the green acquisition, while the band 3 in 0.66 is the red band, the acquisition in the red subspectral bands of the visible. Band 4, that is centered in dot 83 microns, the band 4 in this case is the near infrared bands, while band 5 and band 7 that are centered in 1.6, around 1.6 and around 2.2 microns are centered in the mid-infrared spectral bands. Okay, so these 6 bands are in the same data sets you see here. Why are in the same data sets? Because they have the same geometric resolution, for example. The geometric resolution, so the dimension of the projected cell of the image over the Earth's surface is 30 by 30 meter, 30 by 30 meter on the ground. So I mean, this is not a very high resolution, but this is the resolution that you can have usually using open source data, so free of charge data. Then you have a second data sets that is composed by only 2 different spectral bands, and these spectral bands are called not 61 and 62, but 6.1 and 6.2 that have the same center wavelengths that is around 11 microns. That means that these 2 bands are acquired in the thermal infrared band. So I mean, differently from the previous data sets, the 6 bands, that is recording, I mean, the sensor is recording reflectance that is coming from the ground by effects of the reflection of the electromagnetic energy that is coming from the sun. In this data set with these 2 bands in the thermal infrared, I mean, the sensor mounted on board of this Landsat 7 platform is recording emittance. I mean, the energy that is emitted by the surface and not reflected. So I mean, from the physical point of view, these 2 data sets are representing 2 different, very different physical phenomena, the reflectance and the emittance of radiance, all right, from the surfaces that are placed on the Earth's surface. The last one, dataset, is composed by only one single band that you see is called conventionally band 8, and the central wavelengths of the wavelength range of acquisition is in around dot 7, that is just in the on the border of the red visible bands and the infrared one. Is what is called, I'm sorry, is what is called panchromatic bands. Is only one band, so you will see that we can display that only with gray tones, not in colors like this one. And this is the acquisition that was performed by the sensor using all together, all the visible bands, so blue, green, and red, plus the infrared one, all together from the spectral point of view in one single bands. Considering that acquiring the data in in larger wavelengths interval, wavelength range, that means that we will have more energy going towards the sensor. So if we are having more energy, that means that we can reduce the dimension of the cell acquired on the ground. And this is why this image is in a different data set, because the geometric resolution of this data is doubled in comparison with the first one, because the first one was 30 by 30. Here is 15 by 15. So I mean doubled in both the direction, in X and Y. So that means that is more resoluted, and of course you will see more details on the image. While stating the emitted energy, and we told that and we explained that in the second lecture of the course that is concerning the theoretical part and the emission theory. You know that, I mean, the energy is emitting a very low quantity of energy in the thermal infrared. So having a reduced part of energy, the only way to have energy enough in order to impress the sensor on board of the satellite is just to enlarge the acquisition cell. So that means that in this case, the geometric resolution of these two bands are 60 by 60 meters. So I mean, they are half of the resolution of the first data set that was 30 by 30. All right, so these are three data sets acquired in the same I mean, in the same day, in the same hour, by the same sensor mounted on the same platform, is splitted in three data sets because, I mean, the first and the third one have different geometric resolution. The second one is recording emittance and not reflection like the other two. And so stating, and we will see that in the next labs, we need to process this data, the emittance data, in a different way. I mean, it's separated in a different data set. All right. So, I mean, from here, from the data manager here, we can do some different things. For example, now you will see that because it's the original configuration, when you are loading this kind of data, for example, Landsat, what you get is the visible. I mean, the what you will catch if on board of the satellites. I mean, this is what is called true color image. Because I mean, how we can generate this true color image? You see, if I'm clicking on the band or the data manager, the band selection, you see that I can associate to the three different channel of the visualization of our display, of our monitor, and whatever computer or whatever TV or whatever monitor you are using, they are all based on this particular system. This system that is called the RGB display. R stands for red. You see here the color red. G stands for green, that is the green color, and B stands for blue, that is the blue channel of the association. So I mean TV, but classical software, classical monitors, PC monitors, are using with this RGB system, where you are associating, we can associate a particular band to the three different visible channel of the visualization, and I mean, we can display this image. Right now, the visualization, which is the visualization we have, if we are going to the layer manager here and we are exploding this data, you see that here you have how the association is done. So at the red channel is associated band 3, to the green channel is associated the band 2, and to the blue channel is associated the band 1. That means that to the three colors of the RGB triplets of our output, of our display device, were associated, the three bands acquired in the same colors. So I mean, the effects of this association is that we have displayed what is called technically through color image. Through color, what does it mean, this through? True means that is what we can catch with our eyes. So I mean, it's the acquisition where the red is associated to the red channel, the green subbands is associated to the green channel, and the blue subbands is associated to the blue channel of visualization. So I mean, this is the way, for example, in which our eyes are synthesizing the radiance that is coming from the scene that we are actually observing in order to form an image in our brain. So it's the same system. And I mean, this is the classical true color visualization. But of course, I can also create a more different combination. For example, in this case, I can associate to the red channel the band 4. You see here, I'm clicking that, and you see associated to the red channel band 4, that is an infrared. Then here is switched to the green channel. To the green channel, I'm associating the band 3 here. All right, and then it switched to the blue channel, and in the blue channel, I am associating the band 2. Okay, you see, so to the RGB channel, so the visualization, I've associated respectively the infrared, the near infrared band that is called 4, the red band to the green channel, and the green band to the blue channel. All right. So in this case, you see, I've performed a new association, and now I have two different possibilities. If I'm clicking load data, I'm not clicking that. I can overlap everything to these windows here, or I can check this radio button here, this box here, and I'm telling to the software, please load this new association in a new view. All right. And then I have two different possibilities. Load in grayscale, but this is not in grayscale because it's in color. So I'm just clicking load data. That means load that in color. All right. If I'm clicking load data, you see, and now I'm closing the data manager, you see the central windows of the data display is split in two different parts. And now I'm just seeing two different images, or I mean, two different combination of bands. And you see that having split these things here in two different windows, now you see that in the layer manager, I have two different views. The first one with the overview on is the original one. Now I can put also the overview on the other. And just to explode here, just to check which is the association. Now you see I have these two views active. Of course, the view can come from the same data. I mean, there's no problem. Or they can come from different data. We will see them in the next labs. But you see that now we split that in two different views. All right. You see here from the overview that now I have the same image, but I mean with two different level of view of zoom. And you see here, I have in cyan, in this blue, in this light blue, the Windows 2 that is active. And you see also because you see here is highlighted this name. If I'm lighting this name here, you see now I have the selection of these windows. Pay attention because it's always very important when you have more views to check which is the active views, because on the active views you are performing the analysis and the processing. So if I want to perform some processing on the second view, I have or to select that graphically, clicking on that, and you see if I'm clicking on that, whatever is the icons that is associated to my mouse, I mean, you see that I selected that. I'm doing the reverse, and you see here. But always pay always attention to the frame. This cyan, you will understand what kind of color is cyan here, because I mean it's very important to have these things here. So, for example, if I'm going to these things here, you see that the scale here is because here is the indication of the scale is more or less 1 to 900,000. If I'm going here, you see it's almost 150,000. You see two different scale from here. So I mean, and here on the lower part of the screen, you see when I'm putting the mouse over an image, you see I'm checking, look at the mouse here. This bar in the lower part of the layout of the software, when I put in the mouse here, you see in the middle here, I'm checking the reference system. In this case is UTM with the zone 32 north using an ellipsoid that is the WGS 84. And then when I'm moving the mouse, you see I have the coordinates that are moving. So that means that, of course, as I mentioned before, these data are geo-referenced. All right. Okay. So, I mean, one of the things that is very important when you have more than one Windows that is opened, and so when you have this screen split, for example, in two different parts, is the possibility to move in one Windows and move in the second Windows, in this case, accordingly. So, I mean, if you are moving to a particular spot of the image, I mean, could be very important to move also the other one. So, I mean, for example, if I'm having selected the second Windows, you see here, now I selected the second Windows. How I can be that sure? Because, I mean, if I'm going to the layer manager, you see that is selected the second image. So if I'm going to the main menu here in views, okay, here, I can just use, and you see here we can also in views create a new view. I mean, apart from what we done in the data manager where we create a new views, I can create a void views from here, or I can, you see, for example, split the views in different ways. For example, now I have two vertical, but I can select two horizontal. So you see, now I have two horizontal. If I'm going to views, having active the second views, I can just click link views here. Okay, link views here. What does it mean, link views? Link views means that these two views are both geo-referenced. I mean, the same, of course, they are the same data, but they have the same geographic reference system. So, I mean, I can link, and link means that from the image that I have selected, I linked the second one in order to move from one and having the second move accordingly. So, for example, you see, you have the windows of link views. I have the geolink of the pixel link. This is a geolink, so it's a geographic links. I can just click the here links all. Wait, I'm just moving that. You see that the windows are centered in two different places and they have two different zoom factor. I'm starting from here. So I'm clicking links all, and you see that now I have this route where the view one is the anchored one. So the second will be linked with the other. All right. Okay. I press OK. And you see that now I have the same windows. Okay. So if I'm closing the overview of both of the image, now if I'm moving to one, you see I'm moving accordingly to the second. For example, I want to go to Genoa here, so I'm using the wheel and I'm zooming over Genoa. You see here Genoa, so it's better in this case to have a horizontal split of the screen because it's a linear and horizontal texture, Genoa. Here is Genoa, so this is the visible, what we can catch with our eyes, and the second is a false color. False color, because we associate, is technically called false color, because we associate to the red bands the near infrared. In these windows here, in this four color image, we have something that is very sure. And what is very sure is the fact that, I mean, whatever is red in this image is for sure vegetation. Because when we introduce in the theoretical lesson the concept of the interaction between the electromagnetic energy coming from the sun and the surface on the ground, we mentioned the fact that from the spectral point of view, we introduced the spectral signature, and the spectral signature of the vegetation is characterized by the fact that it is strongly reflective, the vegetation, in the near infrared bands, much more than in the visible. So in this case, if I'm associating the near infrared bands to the red channel of the visualization, whatever is red is for sure vegetation. And whatever is very dark is for sure water,
because you also know the water is very absorptive in the near infrared, but in general in the infrared bands. So I mean, you see here in the just in the inner part of Genoa, whatever is red is vegetation because it's vegetation, while here the water of the sea is very dark because I mean the water is absorbing energy in the infrared. And you see here that in the visible, I mean, we can more or less understand that this is greenish. So, I mean, that could be vegetation, but it's more and more simply to assess the presence of vegetation in this kind of combination of colors. So, I mean, this is why it's so important to acquire the data in different spectral bands because it's very easy just simply looking at the image, I mean, with our eyes, to extract information simply viewing this image. I mean, whatever is red is vegetation, while here in the visible it's not so simple. All right, so we have placed the position in the two screen using the links in Genoa, so we can do another things. So we have recognized a place, and I remind you the final goal of this course is to extract information from data. So we have these data that are numbers that are telling you anything, but when we are just simply observing the image, we can extract information. And when we are extracting information, it's better to label this information. How we can label that, for example, a position, a geographical position in this way. If we are going to the main menu, here place mark, we can add a place mark. What is a place mark? It's just simply a reference to the central point of this view, and we can associate a label. For example, the place mark 1, we can translate the place mark 1 with Genoa, all right? With just press OK, and you see, now in the place mark, you see we have Genoa, all right? So if I'm moving in this image, and maybe I also zoom out here, all right, I'm going in another place. If I'm going again back to place mark and I'm clicking to Genoa, you see, I was bring to the exact position. From here, I can just zoom in, okay? Zoom in, I have this place here. It's a very important thing because it's an airport. This is the Genoa airport, this one. And here you see you have in this false color image the grayish lines that are the runoff corridor for the air for the airplane. And here these rectangle, these red rectangles are simply the vegetation grass that is dividing the different runways. All right. So I mean, how can I be sure that is the Genoa airport? Because I can do another things, and I can do another things starting the possibility to view from other data the position, because you see it's georeference this data. So I mean, if I'm going to views again, you see here, I can just click on these uh, commands here, that is the reference map link. So if I'm clicking to the reference map link, I mean, and now it's very important to have an internet connection. Simply, you see, on the internet connection, it's opened a base map that is centered in your image for example, in the maps. And you see that here is stated that that is the Aeroporto Cristoforo Colombo. You see here. So if I'm switching here and I'm using the same commands as before, because it's another Windows, you see that is, if I'm zooming, this is the Aeroporto. You see here. It is the same things here. I can also switch the base map. You see here, for example, now we are using streets and maps. I can use something different. For example, OpenStreetMap, and you know what OpenStreetMap is. You see here is the airport of Genova. You see there's a script error, but it depends on my case. Don't care about that. You see, this is the harbor of Genoa, and this is the runways. But I can also use, for example, in switch map, in switch base maps, imagery with labels. So you see, I can use that, and this is the image. You see, with some labels. So you see that is the industrial area of the harbor. This is the harbor itself, and this is, of course, the airport. And you see this blue dot here is the place mark I have placed here. But what is quite important here, using the image, is that I can zoom over the image. So I mean, I can have some information more. You see, for example, that here, using the image that are coming from Google, you see I can check there are some airplanes here. Of course, this is in the original image, the Landsat images that I have opened. I mean, there's no possibility to see some airplane, because I mean there's no resolution enough. So you see that I can really recognize this airplane. I mean, pay attention, because these images are not really acquired by satellite, but you know that, for example, in Google Earth or in Google Maps, there's also the integration of aerial surveys. So, I mean, these images were for sure acquired by aerial platforms and not from satellites. But you see, simply using these things here, you see, I can also check if there are some particular boats here in the airborne. You see? I mean, so it's very important to have these reference map links, and so having the internet connection active, because I mean these data are harvested from internet. Of course, they are not available on your software, and you see it's powered by Esri. This is the Esri database that is Esri has an agreement with Google in order to use their image. So I mean, you see, we can have our data linked to a base map, for example. So you see, when I have this base map, I can just close this base maps and go to the back to these things here. So I mean, I can zoom to the airport, and I can add another place mark. For example, add plus place mark. For example, I can call that Genoa Airport. All right, and click OK. All right, so when we are going to the placement, you see I have Genoa and Genoa Airport. So I mean, if I'm going here, I can, for example, move to another position of the image. I moved to uh, this position. You see, this is the upper left corner. You see here there's a shadow here. This is the hill. And you see in the false color, I have this area here. I'm going to this area here, zooming that in the middle, okay? This area here is a larger built up areas, and this is Torino. Oh, you see, I mean, if you are living in Torino, this is the Po River, this is the hilly part of Torino, and this is Torino itself, all right? So let's put a place mark here, and maybe here is better to switch the windows, not having that horizontally. So views, let's go to two vertical views. All right, maybe we are centering that in another position. Let's find again Torino. Wait, I'm looking for that. Here it is. Here is Torino. You see, this is Torino, false color and visible. So I can add a plus place mark, add place mark, and so that will be Turin. All right. And for example, just to check which is that we have also a reference maps. I'm going to views, reference map links. All right, you see, this is Turing for sure. But I'm quite interested in these things here. You see here, I have very large buildings. And so if I'm going, for example, again, to switch the base map, and I have imagery with labels, okay, and I'm closing that, you see, these windows here, I'm just going here, is the FCA, you see here, FCA group factories here. And you see, this is the representation. Here it is. You see that I have all these large buildings where I have the FCA. And this is a very high resolution images acquired by an airplane, of course, because you see here, I also can catch all the single cars, all right? So, I mean, if this is the FCA, you see, this is the center of the image, I can add a place mark, just put in that FCA buildings. Okay, click OK. Then I can go back to the image, just move here. And for example, again, if I'm going to the place mark, I can go to FCA buildings and you see, I will have whatever I selected here. All right, so this is the very first option that we had. So we had, and we place 4 different place marks, for example. And having done these things here, why don't save all these things here? In order, when we will close everything, and maybe we will open that after a while, we can be in the same position. So having used the same data and having the same place mark. How I can do that? Of course, I'm going in File, and I can just save this file, and these views can be, because this is, I'm saving, of course, not the data, because the data are already saved, but I'm saving the views. And associated to the views, I have the place marks, these 4 place marks, right? And with the placemart manager, you see, I have these 4 things here, and I can save or export the placemark. Okay? All right? So if I want to save the views in order to have the same configuration when I will access again to the software, in order not to load all the data, to create the 2 views, to create the links and whatever, I can go to the main menu, File, and go to Views and Layers, and just click on Save. All right, I can save these things here, and for example, I can save as I don't know, whatever, as um, mm, let's say first lab dot, you see, is compulsory to put and to write down this extension JSON. Okay, I can save that in a particular director, whatever is okay for me. Just remember what you are saving this data. And so when I can just press enter or save, and you see now I have saved everything. So that means that after these things here, if I'm closing everything, so for example, I'm exiting, or better, I'm closing all files from here, okay? This is the warning windows. I close all files. Yes, I'm closing everything. Okay, so it's closing everything. So you see, I have still 2 windows, and now I can use another option. So for example, the second windows, if I'm going to the second windows, that of course it's empty, and you see I have selected the second windows. If I'm clicking with the right button of the mouse, okay, I can remove this view. all right? And so I can keep only the first windows. If I'm going here and I'm clicking with the right button of the mouse, of course, I don't have the option to remove the windows because at least an empty window should be there. Otherwise, I'm erasing the central part of the layout where I'm displaying the data. So, I mean, this is the original where we started. So if I want to go to the original position of what we left before, I'm going to File, to Views and Layers, and I'm just clicking on Restore. Okay, on Restore, I put the data here. This is the first lab. Okay, I'm clicking that. I'm opening, and you see, it's creating the same things as we left them. You see, I mean, it's not the saving of the data, but it's just simply the saving of the configuration of the layout. So the possibility, the data that we have loaded, the place mark are there, you see are there. And then if I'm going to the data manager, you see that I have the same data. And if I'm moving on one image, for example, zooming here, you see also the other is zoomed. So I mean the links is active. So I'm went to the same and exact position as before. All right, so we can consider this first laboratory concludes. Conclude. I mean, what we learned is just to have a description, a general description of the software, and we learn how to display data and to initially extract information from the data itself using, for example, the position of a particular object, and so recognizing the characteristics of particular features that we have on the ground. And this is from the geometrical point of view. I think something related to the position of particular features, but we also starting to mention the fact that using different spectral bands and part of the spectral bands that are not sensitive to our eyes, we can extract simply viewing the image some information like the facts that in the false color composite, when we are associating to the red channel of the visualization, for example, the near infrared, we can notice that whatever is red is connected to the vegetation and whatever is very dark is connected to water. And so also from this last view here, you can simply understand that here, this is the hilly part of Torino. Here is very simply to check in red what is vegetation, while you see here using the true color image is not so simple to understand that this is vegetation. And I mean, and also you see here the Po River is more contrasted in the false color than in the visible. So I mean, that is very important for the first labs and to have learned that in the first labs. So I mean, thank you for your attention. We will see the next lab and pay attention, just practice on this software by your own in order to understand and to practice with the initial commands that we have already presented. Thank you again and take care, and we will see next time for the next lab. Of course, before leaving you, we can just exit from the software. So going to the file, to the main menu, to the file, and just to exit. Bye bye.